Now coming to the last discussion of the renal system, which is cystometrogram. This cystometrogram is in recent trend and they are repeatedly asking questions from it. It is very simple, but still there are repeat questions from it. What is cystometrogram? Cystometrogram is a graphical representation between the bladder volume and the bladder pressure. They are just seeing if the volume of the bladder is increased, what is happening to the bladder pressure. This has been studied. This cystometrogram studies are done in urology tests. Why? Because to assess the bladder extension capacity and to assess the micturition defects. So what they did is whenever the bladder volume is filled, this is an experimental setup, but this can be done in a humans also and observe what is happening. So whenever the bladder is starting to fill, there was an increase in pressure. As you can see here, the first part of the curve, there was an increase in pressure. Whenever the bladder was filling, there was an increase in pressure. And this segment is named as 1A. What is happening in 1A? There is an increase in volume, and this increase in volume, bladder is like this, the volume is increasing. So what will happen to the pressure? The bladder pressure also increases, increase in pressure. This happens till at some point only, this point only. At this point, what happens is there is a first urge for micturition. There is a first urge for micturition. Sometimes when you drink water, you will feel like micturating. The first urge happens here. And what is the ml here? Suppose if it is plotted against the ml, it is around 150 ml is the first micturition happens. Then the next segment of the curve is our MCQ segment. This next segment is our MCQ segment. Here you can see here the bladder volume is increasing, but the pressure stays constant for a longer period. Here the pressure is staying constant for a longer period. How is this happening? This segment was named as 1B. What is happening in this 1B? Because here the volume is increasing, but pressure is staying the same. Pressure stays same. This is because of the property of the bladder muscles. The bladder muscles have the property to distance. So all of us know one law, that is Laplace law. This is the question as which law operates in this part of the segment, and sometimes they give this segment and as the reason which is why this segment is flat, and the reason behind it is the Laplace law. Laplace law states that the pressure is equal to 2T by R. Here the pressure is equal to twice the time of tension. T is for the tension divided by the radius. What is happening here? Whenever the volume is increasing, the tension should increase. The tension should increase. So ideally the pressure should increase, but we are not seeing a pressure increase. So who is compensating for that? The radius of the bladder is also increasing as and when the tension is increasing. So just imagine it is getting filled, but at the same it is enlarging. So that it will not act on any pressure because now the radius or the diameter or the whole capacity is increased. So that is the reason here the volume increases there, but still there is no pressure increase. It operates on the Laplace law, and here the tension factor as well as the radius factor, both of them are increasing simultaneously. So this is the segment 1B. And coming to the third segment, whenever the volume reaches 400 ml, for example, 400 ml or more than that, what happens is our urge for micturition starts. Then after this, you cannot hold it. After this, whatever person is teaching the class or anything, you just want to take a break. What is this segment? This segment is the one where the micturition reflex becomes very strong. It becomes very strong. And as you can see here, it keeps on increasing the pressure and decreasing the pressure like this. It keeps on going up and down like this because it will cause a severe urge of micturition. And finally, the only relief factor for this is going and micturating. So this segment is nothing but our micturition reflex. So this diagram, all the parts are important. 1A, 1B, and this is segment 2. Why they haven't named as segment 2? Nobody knows. It is the micturition segment, so they have named it separately. 1A is due to the pressure increase, 1B is constant due to Laplace law, and 2 is due to the increased micturition reflex. This brings us to the end of renal physiology. Thank you.